Hi, this is Jeff with Sabe, and this is the third video in our series about Sabe and DDMRP and buffer management. In the first video, we set up this master information down here with items and sites, making item sites, assigned to planning category or policies, and then assigned to planning categories. In the second video, we took a look at live data and used the update planning parameters and planning profile assignments to create actual red, yellow, and green zones. And here in the third video, we're going to be talking about the material planning workbench, which is actually where the rubber hits the road. So I'll go to the material planning workbench, and we have this item that we're dealing with, which is a configured bicycle, 5944-XC, search, that guy right there. We have it in 3 sites, manufacturing, retail north, and retail south. So I'll click on retail north, manufacturing. And you can see that Sabe immediately loads the planning parameters for this item site. We have top of red, yellow, and green. We have the absolute values of demand spike threshold, demand spike horizon, demand spike threshold. We have the quantity on hand and the net flow. We also have all of the demands and supplies down here in running availability. At the moment, you can see we just have demands. We'll talk about a requisition list in just a little bit, but basically demands from Sabe come from sales orders, work orders, maintenance orders, requisition lists, and miscellaneous demand. So the easiest way to inject demand is requisition lists, and that's what I have right here. I have a net flow calculation. I start with a quantity on hand of 13. I have no open supply. This is old demand for a total stock of 13. I have a current demand of 4. So current demand is demand that's due today or is late. And that's that item right there. That demand right there is 4. A qualified spike of 3. So my demand spike horizon is 4 days. My threshold is 1. I have 2 orders, or 2 demands, that fall within that 4-day horizon, and both of them are greater than 1. So both of these demands right here represent qualified spike. So I have a total demand of 7. My total stock minus total demand is my net flow position. Now right here we can see that running. We can see that we start off with 13, I consume 4 is 9, and then I consume 1 is 8, and I consume 2, which is 6. This demand right here is grayed out because it does not fall under either the definition of current demand or qualified spike. It's the quantity allocated of 3 certainly meets the threshold demand, but if you look at the date, that's outside of the horizon. So to see that at work, what I can do is I can change the definition of demand spike threshold so that it is greater than the demand quantity of this demand right here. This requisition list is demanding 1. The demand spike threshold is 1, so it's met. So if I come into here, into planning policies, oops, and this is the MFG planning policy, you can see my demand spike threshold 16% of the red zone, which is probably less than 1, but of course we roll up. So if I change that to 54%, save it, and refresh this screen, you can see immediately this demand, the demand spike threshold went from 1 to 2. So I think it's 54% of 3 is greater than 1, and it rolls up to 2. And that means that this demand right here no longer makes a qualification for qualified spike. So where qualified spike was 3, these 2 demands, now it's 2. This demand here, this demand is grayed out, indicating that it does not contribute to total demand, and my net flow position is adjusted accordingly. So this is our summarized net flow. This is the summarized arithmetic, and here is the demand by demand contribution to current demand and qualified spike. So here's the detail, and here's the summary. This does not, however, show a replenishment plan, and that's because I cleared the replenishment plan out prior to running this video. Normally, the replenishment plan is created nightly after the update planning parameters and the planning policy assignment utilities are run. But what I'll do is I'll right mouse click and I'll create planned orders just for this one item. And we can see now Sabe's creating a planned work order for 22. The 22 brings me back to top of yellow because remember my net flow position was 6 or 7, which is lower than top of yellow. So an order of 15 is issued or is planned for 15, which brings my net flow position back up to 22. Now, This is really interesting to play with. It's a nice diagnostics tool, just in the same way that update planning parameters and planning policy assignments are great ways to see how mechanics work. I don't want my planners here all the time. This is item by item planning and it doesn't work. What I want my planner to do is react to the suggestions, and the suggestion is a planned work order to establish a net flow position. So what I want my planner to do is come in every morning and go to the planned order workbench, and you can see there's some other plans. But this right here is that planned work order we're talking about. It's the 15. It has a due date, which is actually today plus the lead time. And what I want my planner to do is right mouse click and go to the material planning workbench to get the detailed information if they need to understand why that planned order has been issued. Or they can right mouse click and they can release the planned order right from this screen. So if they release this planned order, Sabe will create a work order and send that to the production workbench. However, we can see with this graphic right here, this is my buffer penetration. This is of this remaining quantity right here, how much is being allocated. And that red exclamation point means that you should not release this planned order because we're missing components. So with the right mouse click, I can take a look at inventory by bill of materials, and I can see we're missing this component right here. So we're going to be doing a video that talks about this graphic right here, constraint statuses. But when DDMRP is installed, when the buffers are, the buffer profiles are established, when the top of yellow, top of red, top of green are established and understood, what happens is the planners come in every morning and they take a look at the advice. And they release that advice, which they can. They can drill down and they can take a look at the reason for that advice. And they can better manage their replenishment, allowing DDMRP to manage those, which we've decided are buffer managed, and using more traditional tools to manage the make to order and engineer to order parts. So that's DDMRP and buffer management in Sabe from an execution point. In the next video, we're going to talk about the analytics side. We're going to look at a buffer simulator and take a look at a buffer visualizer to see if our plan's actually working. We'll see you there.